Hey, we're moving on now. All right, we're on to section 3.9. Okay, this is for your exponential terms. We're going to do derivatives of exponentials. And what I want you to do here is first be able to identify what is exponential versus a power term. Okay, so there's a couple of things I want to do here. So here we go. So how do I determine exponential terms? Exponential terms, okay, those are going to have x in the exponent. Okay, power terms are going to be to where, okay, x is in the base. Okay, so when I take a look at this, I gotta go, well, this one's kind of obvious right here, right? This is, and I want to identify this. This one's going to be exponential. Yeah, I'll put exp. Okay. And this one here is kind of obvious, right? This one's going to be power. But ones that you need to be careful of, okay, is sometimes when there's neither. Okay, so when I do e cubed, we got to remember, what is e? E is a number cubed. So is this a power or an exponent? It's really neither, because I have a number to a number. So this is just a big giant number. E cubed is just like saying 2 cubed. Okay, so that's what you have to worry yourself about. So what I want you to do is I want you to take a moment. I'm going to pause the video, and I want you to do the rest of these and identify them as exponential, power, or neither. All right? And there you go. Check your answers in red, see if they're correct. If you need to, pause my video. All right, and check them out. All right, next. I want you to do the same thing with these. I want you to identify them as exponential, power, or neither, because it's a number. And boom, there they are. Now what I want you to take special note of is the ones that I said here were, you know, this one here being a power function, yes, because that's pi is a number, x is in the base. This is exponential because it is pi is a number, x to a base. And notice the ones that are neither, okay, yes, neither, because this is a number to a number, okay. And yes, this is power because it is raised to the first power. All right, here we go. Next slide. So the reason why we did all that is because I now want to take derivative of exponential functions, okay? And whatever you may be thinking, okay, it is not the same as the power rule, okay? So if you see an x in the exponent, you got to be thinking to yourself, this is a completely different problem. It is not the same as an exponent, you know, like x squared. It is not the same. So here we go. Again, not the same. So what is the derivative of e to the x? The derivative of e to the x is, drum roll please, e to the x. Say what? That's right. Taking the derivative of e to the x is the exact same thing of the natural exponential. It's just a carbon copy. It is the exact same thing. Okay? So derivative of e to the x is e to the x, which you got to think about yourself is just a crazy, crazy concept, right? Why? Because the function values are describing its own slope at every point. So whatever the function value is at e to the third is also the same as the slope value for e to the third, which is just crazy, right? Okay. So then it comes down to, now what about if I have any other base other than e? What is my derivative going to be? My derivative is going to be the rule natural log of that base times the exact same carbon copy. So again, derivative of the other base, exponential is a carbon copy, times the natural log of that base, since the base is not natural. The reason why I bring this up is because, take a look, I could use the same function here, same rules here, right? Okay, that the derivative of e to the x, excuse me, is equal to the natural log of e times e to the x. But now we need to bring back our log rules, bring those back into our brain. And we have to remember, oh yeah, natural log of e is the same thing as saying just 1. So that's why it is e to the x. All right? All right, if you want an actual proof of it, go look it up online. It's a great proof. It's amazing. But if you're not interested in that, just keep on rolling. Just trust it. It's the Church of Math. Let's go next. Okay, so now we're going to just spend some time doing some examples, and we're going to go through these pretty quickly. So I want to determine the derivative for each of these functions. So if I want to do y prime, I want to take the derivative of 7e to the x. And I need to break this apart as saying, well, 7 is a constant, e to the x is my function. So when I have a constant times a function, I leave the constant alone, and I multiply it by the derivative of the function. The derivative of e to the x is e to the x. Okay, derivative of minus 5, 0. So there's my derivative. Boom, there I am, all done. Next one. All right, so I got to break this up. I got two separate functions here. All right, I have two separate functions where this is 2 times x squared. Again, this is a power function, so I'm going to use my power rule, which is going to be 2 times 2, which is 4x to the first power, plus, and this is going to be that exponential. So the exponential one is take the natural log of 4 times 4 to the x. And there I am. I'm all done. Boom. Lots of 4s, but there it is. I'm all done. Cool. Let's do the next. Okay. Number 3 is a lot like what I just got done doing. So what I want you to do is we're going to pause the video here. And I'm going to have you do number 3. Hold off on doing number 4. Ta-da! There's your answer. Okay, y prime is 7e to the x plus 8. Okay, hopefully you got that. If you did not, please bring that up in your questions part at the end of the video. Next, example 4. So what I've got going on here, okay, now this is where you got to start, getting in that anxiety. There's a little anxiety when I look at this one. You need to hold that in. Why? Because it's natural log of 5. What the heck is that? Okay, it's natural log of 5. You got to just think of natural log of 5 as any number. Okay, any number. So if it's any number, well, that's just like a constant. It's just like, oh, okay, so it's like my constant times a function. Well, I'm just going to leave that alone. It's the natural log of 5 times, and then whatever that is. Well, derivative of 2 to the x, well, that's natural log of 2 times 2 to the x. And that's what y prime is equal to. Okay? And you may think you can simplify. There are some things that you can do, but it just gets crazy more complicated, and you don't have to worry about all that. And you just circle and box your answer. Okay? We got 2 more examples to go through. Here we go. So example 5. Whew. Now it's starting to get a little crazy, a little crunk, right? So here we go. I have y prime. I'm going to rewrite this. I'm not going to just straight off and do the derivative. This is getting a little complicated here. So again, when I see this, I need to see this as, hey, I can break this fraction up. I can make this 1 over 5. Okay, 1/5 times 2 to the x minus 2 times 5 to the x minus ln of 4. Now what I got going on here is now I go y prime. Now I have a constant times a function. So again, constant, leave the constant alone. Times a function, derivative of the function, derivative of the function, natural log of 2. Okay. Times 2 to the x. Okay. Minus, again, constant times a function, 2 times ln of 5 times 5 to the x. And then derivative of the natural log of 4. Okay, and this is where you got to pause again and be thinking, oh, natural log of 4. Natural log of 4 is a number. I can put that into a calculator and it gives me a number. So when I take the derivative of a number, I should get 0. And then to clean this up a little bit, there are going to be some things that you can do for your natural log rules that may help you out in finding multiple choice answers. So one of the things that you have to remember is that a number times a natural log can be rewritten as, let me change colors here, okay, y prime is equal to natural log of 2 raised to the 1/5 power times 2 to the x minus natural log of 5 squared times 5 to the x. All right. And I'll just clean it up a little bit so you can be able to see sometimes your multiple choice answers end up where it's cleaned up a little bit. Okay. For a free response question, the first one would have been fine. Okay. So let's take a look here at example number 6. Again, we can't freak out. And you see the natural log of 3. Ah! Okay. Again, natural log of 3 is just a number raised to an x. So again, I'm dealing with an exponential one. So what I'm doing with exponential is y prime. So my exponential says take the natural log of the number. Well, what's the number? The number happens to be the natural log of 3 times, well, then the carbon copy of it, natural log of 3 to the x power. And there it is. There's my answer. There's a lot of natural logs, okay? But there it is. That's the answer. All right. Last thing I'm going to do is that you have an example. I took one of the homeworks from your D cubed worksheet, number 6. Here's number 6. It's right here for you. What I want you to do is I want you to be able to take a look at this, and I want you to do it, and we'll see if you get the derivative. So find the derivative of this function. All right. And bada bing, there it is. All right. Hopefully you got that correct, and you were able to get that right. Down below there is the homework. Your homework is due at the in a couple of days, and we're going to have the quiz on this in a couple of days. So make sure that you start the homework so we can have some questions there for you. Okay? I know it looks like a lot, but this first part here is what we learned today about exponentials. This second part down here, part 2, is all about product and quotient rule, which you should have down by now. All right? All right. See you guys tomorrow.